All right, welcome to the last lesson of Unit 4. We are going to be looking at something today called Cramer's rule, and what this is another method for solving systems. I know you may be thinking, why do we need another method? But I really just want you to see how matrices can actually help us. And the good thing about Cramer's rule is that it only involves determinants. It does not involve any matrice or any inverse matrices. And so you don't have to go through the pain of like 1 over 13 minus 5 over 13 and doing that kind of math. So it looks a little intimidating at first, but let's look at what it's saying. We are always going to keep our x coefficients, our y coefficients, and our constants together. So you can see here that like the constants vertically will always line up. The y coefficients will always line up, and the x coefficients will always line up. So what this is saying is that we first are going to take the determinant just of the coefficients of x and y. Okay. Next, to find the determinant of x, we are going to replace the x column with mn, or with our constants. And so the way that I just kind of remember it, because I can mix it up sometimes, is I remember that whatever this letter is the letter that I'm replacing. So I replaced my x coefficients with the mn. And so then in the y, I replaced the y coefficients with mn, but this part stayed the same. And then to get the solution, I'm going to say that the x coordinate of our system of equations is given by this determinant value over this determinant value. So it should be just a number over a number. And then for the y coordinate, I'm going to take this number over this number. Sounds a little confusing in theory, but let's try it and see what happens. So I'm going to set up 3 different determinants. I'm going to have d, I'm going to have d sub x, and I'm going to have d sub y. So let's start with just d. This one is the easiest one, I think, for people to remember because it's just taking the x and y coefficients. So it's 3, 1, 2, 3. And when I do that determinant, I get 3 times 3 is 9, minus 2 times 1 is 2, so I get 7. So this is the value of d. For d sub x, since this is the variable that I have written, it's the one that I'm replacing. So I'm replacing 3, 2 from this determinant with 5 and 8. But the y's will stay there. So when I do this, I get 5 times 3 is 15, minus 8 times 1 is 8. And I get 7. And finally, for d sub y, I get, I'm going to keep my x's, but I'm going to replace the y coordinates with 5 and 8. And so this would give me 24 minus 10, which is 14. So to get my x coordinate, I'm going to do dx over just d so that would give me 1. For y, I'm going to do dy over d, which would give me 2. So when I write my final answer, it would be 1, 2. And if I check it, it would be saying that 3 times 1 plus 2 is 5. That's true. 2 times 1 plus 3 times 2 is 8. And that's also true. So that means that we did this correctly. So I know I have a couple of reasons I like Cramer's rule. I have a couple reasons why it's a little tricky. What do you think are some pros and cons of this method? I would say that one of the pros is that I don't have to deal with the inverse matrix. The inverse matrix means that I'm usually dealing with fractions and I'm having to do something like we looked at a problem where we had to do this. And even though they have a common denominator, I just don't like having to get negative 39 over 13, which equals negative 3. I don't like having to deal with that. This way I don't have to deal with fractions. One of the cons, I would say, or one of the drawbacks, is that it is something that you have to remember. It is a formula, but it's just another thing to remember. So that is one of the drawbacks. But we're going to continue practicing, and hopefully it won't feel like such a drawback by the end. Okay, so I'm going to set up my determinants, and I'm going to have first 2, negative 1, 1, negative 3. For dx, I'm going to replace the x column with 10 and 0, and then keep my y column. And then for dy, I'm going to keep the x column and replace the letter that's here. So I'm going to replace it with 10, 0. So when you take the determinant of each of these three, what do you get? When I do this, I'm going to get negative 6 minus negative 1, which is 5, negative 5. Over here, I'm going to get negative 30 minus negative 1, or sorry, minus 0, which is negative 30. And then over here, I get 0 minus 10, which is negative 10. So when I write this, I'm going to get x equals my dx over d. For y, I'm going to get dy over y. And so my final answer would be 6, 2. And then because it doesn't take me very long to check, I'm going to make sure this works. This would give me 12 minus 2 is 10. That's true. This would give me 6 minus 6 equals 0. That's true. So that means that this is our correct answer. All right, let's make things a little complicateder, and we're going to throw in x, y, and z. Now, you don't need a formula to do this. It's the same basic principle where I'm going to start with just d, and it's going to be 1, 1, 1, 1, negative 3, 2, 3, 2, 4. I'm just taking the coefficients of x, y, and z. Next, I'm going to do, oops, my bad. Next, for x, I'm going to replace the x column with these numbers. Oops, it should be 1.26. And then 4.06, 2, and 4. Now I have dy equals, and I'm going to replace the y column this time. So I'm going to keep the x's the same, and I'm going to keep the z's the same, but I'm going to replace that y column with 1.28, 1.26, and 4.06. And finally, needed that to be the same. Finally, I'm going to set up my z matrix. So I'm going to have d sub z equals, and everything's going to stay the same for the first two columns, 1, 1, 3 down, and 1, negative 3, 2, working our way down, because those are the x and y. So then this one would become the 1.28, 1.26, and 4.06. Now, we are going to find the determinants, and I have good news. We're going to look at how to do determinants in our graphing calculator. All right, so we are going to enter our first determinant in, or our first matrix in. So I'm going to go to Apps, Data Matrix Editor, and I'm going to go ahead and open a previous one. We've already created some 3x3 matrices, and so I'm going to just use one that we've used before. So I have to change the type to matrix, but then you can see down here under variable, if you arrow over it, it'll give you a list of all the different letters that you've used. I used A to make a 3x3, so I'm going to hit enter, and it's going to pop up the last matrix that I made on that 3x3. So in this case, the one that I'm making is 1, 1, 1, 1, negative 3, 2, 3, 2, 4. Now, if you want to calculate this by hand, you can, but you can also go to the home button, and then you're going to hit second 5 because you want that math function. And number 4 says matrix, so I'm going to click 4, and then I'm going to go down to the second one. It says DET, and that stands for determinant. So I'm going to say determinant, and I want to say that it's the determinant of matrix A. And I need to close my parentheses, and guys, this is a magical moment. It tells me that my determinant is negative 3. So that's my determinant for just D. Now if I want to do D sub X, I can again write over that. I don't need to keep that matrix A. I can just recreate or write over it. I'm going to go to 6, and I'm going to go to open, change this to a matrix, and I'm going to still use A, so enter. And I'm going to now use 1.28, 1, 1.26, negative 3, negative 2, 4.06, and then everything else will stay the same. And so now when I go home, actually I can just use exactly what's typed there, and now my determinant is negative 2.7. So try finding the determinant of D sub y and D sub z and see what you get. So when I did this, what I got for D sub y was negative 0.24. And what I got for z was negative 0.9. Over here, let's put these values in. This one was negative 3, and the other one was negative 2.7. All right, so these don't look like fun numbers, but my calculator is going to help me out here. I'm going to get D sub x equals negative 2.7 over negative 3. D sub y equals negative 0.24 over negative 3. And D sub z equals negative 0.9 over negative 3. And when I do this in the calculator, I'm going to have negative 2.7 divided by negative 3, and I get 0.9. So see what you get for y and z, and then come back and check your answer. All right, you should have gotten 0.08 and 0.3. So that means that if we write this as an ordered triple, we would get 0.9, 0.08, and 0.3. Not the prettiest numbers, but I won't give you anything that's much trickier than that. So that's how to use Cramer's rule with 2 and 3 systems or 3 equations in your system. If you have any questions, let me know. I would be happy to help you where you have concerns.